All right, today we're going to be working on slope and perpendicular lines, and that's going to be on 86 and 87. So we're going to label that slope and perpendicular lines. It's going to be very similar. We're just going to talk about things that are perpendicular now instead, such as rectangles, squares, those kind of things. So 10.2, slope and perpendicular lines. So label 86 and 87, 10.2, slope and perpendicular lines. Let's talk about slope criteria for perpendicular lines. Now, you've heard of this many times, just in a different way, and I'll explain what I mean by that. So slope criteria for perpendicular lines. Two non-vertical lines are perpendicular if and only if the products of their slope, meaning when you multiply them together, product, not products, product of their slopes is -1. Now, what you're used to seeing is not this. You're used to seeing that they're opposite, meaning one's positive, one's negative. Reciprocal, meaning they're flipped, okay? But opposite reciprocals, when you multiply them together, is -1. That's where that idea comes from, okay? You are going to rip out page 512 and 514. You will also need a small piece of graph paper if you're in class. I've given you a little note card, or we'll be giving you a little note card. If you're at home, you're going to need to make a piece of graph, or grab graph paper if you have some. So 514. And 512. Books are almost done. As soon as we get to 10.5, when we're done with 10.5, we'll get a new book, actually. When we get to 11.1. I do not know what I've done with my scissors. There they are. Okay, you need number 5 from 512. Actually, you do not need a piece of graph paper. We're going to cut very carefully. On number 5, and you won't need graph paper, okay? I'll show you what I mean by that. We'll have to write the instructions, but nothing else. And I kind of messed mine up slightly, but that's okay. Okay, from 512, and you also need something from the back. You need this, and don't cut it off like I accidentally did. You need the whole thing, so I have to glue that to the bottom because I accidentally cut it off. But you need this, and you don't need a blank space because we're going to take the picture from the back and then you won't need a note card or anything. So glue this in right here. And like I said, I kind of accidentally cut some of my stuff off, so I'll have to glue it together since I cut it off on accident. But that's okay. So number 5. Okay. And then we're going to write the instructions real quick for number 6. So skip just 2 lines right underneath this and write number 6. Number 6 is going to say, show that JKLM is a trapezoid with 2 right angles. And then we'll get that picture from the back of what we just cut out. So JKLM, the trapezoid, is on the other side of what you just cut out. And I cut mine in half on accident. Don't be me, evidently. I'll show you what it looks like when I piece it together. Of course, I would do that in the middle of the video. Makes sense. Part of it. And I'll show you the other part. Here's the second half. There we go. So that's what you're cutting out. All right, now from 514, basically you need the whole page. You're just going to trim it down. So from 514, you're going to glue on 87, the whole page from the word street equation on that box all the way down to this graph. That's what you're gluing in on 87. We'll get started on the examples. Okay, so using slope and perpendicular lines is going to help us to prove things about something with a right angle. Okay, so number 5, show each figure, and 6, this is instructions for 5 and 6, show that each figure is the given type of quadrilateral. So we are supposed to show that DEFG is a rectangle. Now, the definition of a rectangle is that you have 4 right angles. We have to show that we have 4 right angles. So to show that, we are going to have to find the slope of all 4 sides. So we are going to be finding the slopes of DE, EF, FG, and GD or DG. Okay. So we're just counting slopes. To get to D, from D to E, I go down 1, 2, 3, 4, -4 over 1, 2, 3, 4, 5, 6, which reduces to -2/3. Okay. EF, 1, 2, 3 over 2. FG, 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, -4 over 6, which reduces to -2/3. GD, up 1, 2, 3 over 1, 2. Okay, to show that something is a right angle, I need to show that something is perpendicular. So let's look at what we've got. We need something that has a product of -1, which is the same as the opposite reciprocal slope. So look right here, DE and EF, I have negative 2/3 and 3/2. Those are opposite reciprocal slope. That means with these two, angle E, which is the one they have in common, is a right angle. Okay? Now, let's move on to the next one. EF and FG are also opposite reciprocals. So these two mean angle F, because that's the one they have in common, is a right angle. Okay, look at these two. I'm going to go this way now. FG and GD are opposite reciprocal. So angle G is a right angle. Okay, that's 3 right angles. Next I need D. These two share D. Opposite reciprocal, so angle D is also a right angle. With 4 right angles, DEFG is a rectangle. You are proving it based on the definition. Let's look at number 6. I want you to pause the video and try it. Think about the definition. Show that JKLM is a trapezoid, meaning you need one pair of parallel sides, same slope, with 2 right angles. You have to prove that 2 of the angles are right. Okay, let's think about what we need to find. Looking at the picture, we need to determine which ones we think are parallel to prove it's a trapezoid first. And from what I see, it looks like JK and ML are probably parallel. So let's find the slopes of those two first. Slopes of JK and ML. JK, I'm going to go down 1, 2 over 1, 2, 3, 4, 5, 6. So negative 2 over 6, which reduces to negative 1/3. Okay, and then ML, down 1 over 3, so 1/3. So JK is parallel to ML. So JKLM is a trapezoid. Okay, we got the first part. Let's get the next part. Right angles. Where do you think the right angles are? I'm thinking they're probably at K and L, which means I don't have to find JM slope. I probably just have to find the slope of KL. KL, go up 1, 2, 3 over 1. Okay, now look at these. JK and KL have opposite reciprocal slope. They both share K. And angle K is a right angle. Okay, now look at this one. ML and KL, they share L. They are opposite reciprocal, as is angle L. Angle K and angle L are 2 right angles. So, since they are parallel, JKLM is a trapezoid, and angle K is a right angle, as is angle L. Therefore, JKLM is a trapezoid with 2 right angles. So we have proved that it is a trapezoid with 2 right angles. We're going to work on the line section on the next one over here. Okay, the lines. We're trying to determine the type of quadrilateral that's created by the streets that we're given here. So we're given streets, we're given an equation, and they break it into steps of how we would do this. So step 1 says write each equation in slope-intercept form. So we'll start with Clay Avenue, meaning we need to solve this for y. To do that, we're going to add 9. So it's actually 3y equals x plus 9. And then we're going to divide by 3, which gives us y equals 1/3 x plus 3. And that's what we're going to write in the blank down here, okay? 1/3 x plus 3. Right, next we're given 2x plus y equals 3, which means we're going to subtract 2x, so y equals negative 2x plus 3. Negative 2x plus 3. Okay, next we have 3y equals x minus 5, so we simply divide by 3. Y equals 1/3 x minus 5/3, which will be hard to graph, but okay. And last, y plus 4 equals negative 2x, so we're going to have to subtract 4. So y equals negative 2x minus 4. Okay. Now, look and listen. I cannot stand doing stuff for no reason. Number 2 says use the equation to determine the slope. They want you to rewrite the equations again. Why? I don't know. We are going to write the slopes down though. The slope for Clay Avenue is 1/3. The slope for Fresno Road is negative 2. Ward Street, 1/3. Oakland Lane, negative 2. The slopes of the opposite sides of the quadrilateral are these two and these two are the same or equal. They are not opposite reciprocal though, so which one was the same? Parallelogram. Since the opposite sides are parallel. It would have been a rectangle if these were 1/2 and 1/2. Okay, let's graph. Here's how we graph these lines. Clay Avenue is at y equals 1/3 x plus 3. Start at 3, go up 1/3, and connect. So that's Clay Avenue. Put a little C for Clay at the end of this line, just so you understand that that's what this one was. This is C for Clay Avenue. Okay. The next one, Fresno Road, starts at 3 as well, but it's negative 2 slopes, so you go down 2, right 1. This will be F for Fresno Road, and I think that blue has messed up my red pen. No, just at that one point, so that's okay. F, this is Fresno Road. Okay, Ward Street is negative 5/3. That's close to negative 2. I'm going to go up 1/3. That's hard to graph, I know. I don't have any idea why they have made it a negative 5/3. I can't help you with that, but this is W for Ward Street. And last is Oakland Lane, so negative 4. Down to right 1, we cannot do that, so up to right 1. Oh, left 1, sorry, not right 1. Okay, we're looking to see, does this really look like a parallelogram? And the answer to that is yes, this in here does look like a parallelogram, okay? All right, so that's slope and perpendicular lines. As you can see, even though this is slope and perpendicular lines, you will get parallelogram stuff mixed in because you've already learned it, okay? Go ahead and do the assignment that is posted on Google Classroom. And I'll see you in the next video.